Alright guys, let's get started on restoring this Philco 49901. And remember, this is not a foot operated radio. It is an unusual desktop. Alright guys, let's get started on restoring this Philco 49901. And remember, this is not a foot operated radio. It is an unusual tabletop hand operated radio. Had that confirmed on the Philco forum by none other than the man himself, Ron Ramirez, who knows more about Philco than anybody else. Alright, so, two major tasks. Well, one major task, that's the cabinet. The other major task, of course, is to get it to work. So, I did a little research, did a little shopping. Let's talk about the cabinet first. So, this was originally painted. I found the original color schemes. I think came in 3 different colors, none of which are particularly attractive these days, but I think I'll try to pick one of the original colors. So this would be the off-white or ivory. I think there was also sort of an avocado light green, and I forget what the third color is, but they're all kind of muted, sort of 50s-ish, late 40s type colors. So I want to strip off that old paint. I've tried pretty much every stripper out there. I've never found anything that works better than Citrus Strip Plus. It's the least toxic of them all. It smells nice. It's, well, based on citrus, I guess. Still, you don't want to get it on your hands. It's not as nasty as methyl ethyl chloride or some of the other stuff. But this works on polyurethane. Shellac, lacquer, but basically anything. I've stripped several Bakelite radios with this stuff. Whatever paint they used on these originally, this stuff really holds. So you're going to need a strong stripper. Something like lacquer thinner is not going to take this off. Alright, then I need to start repairs. So I did a little shopping and got some products here at my local home improvement center. So, first off, super glue. And you want to use the kind that sets up fast. That's the purest, the thinnest. You don't want to get the stuff that's gel, because what they do is they add extra stuff to it that retards the curing process, adds some body to it, but it's not as strong. And notice how this is our strongest and fastest. That's the trade-off. If you want it to be strong, it's going to be really thin and set up pretty fast. And the trick I've read about doing this, in the past I have applied glue and then pressed the halves together. Bad idea. What you want to do is clean out the cracks with lacquer thinner or acetone. Get as clean as you can, clamp it up as tight as you can, then apply the glue on the inside, and it will wick down into the seam. So this may look tight, but when I feel it, my finger's catching. This surface is a little bit higher than this surface. So when you work on these kind of complex curved surfaces, it can be a little tricky to get it clamped up. Just putting a clamp on this way, not going to do it. I'm going to need to also clamp it somehow this way too. So I'll have to put one clamp on it this way and another this way, because it's cracked both here and here, and this crack kind of runs down along. Now, I have some leeway here, of course, because it's going to get painted. So I can use filler and I can sand it, and mistakes will be obliterated. If you were going to actually have this be a natural polished Bakelite surface, and it's especially important to get these cracks sealed up super tight. And then there's, well, you can see the other issue I've got. There's a big hole there. And along the edges, not on the top piece luckily, but on the bottom, I got a lot of damage to the edges. To where this, I don't know what happened here, but this, it's like a dog chewed on it or something. This whole lip is gone here. And here. And up here. And it's cracked as well. So what am I going to do about that? Well, I picked up some fiberglass cloth like you'd use with Bondo, but I don't want to use Bondo. You could, but I'm going to go with JB Weld. You could also use epoxy resin, or stuff that's meant for the marine environment is especially strong. This I'm familiar with. I know, in fact, I've repaired another Bakelite cabinet with it. I know I could use it as a good filler, and then once it sets up, you can work it. You can file it, you can sand it. It doesn't shrink, and it takes paint well. And I got the fiberglass cloth well to apply backing here. Some guys also will apply it along the cracks to reinforce them. I found super glue, if done right, is pretty darn strong on its own, especially if it's a surface that's not going to see a lot of pressure, a lot of force exerted to it. It's sufficient. But since I'm going to be doing this hole anyways, I might as well apply a little cloth along here and along here. You could use two-part epoxy, but this basically is two-part epoxy, but they add, I believe, some sort of iron particles to it. That's why it's gray. Anyways, yeah, as they say, it can be sanded, even drilled. You could like drill this and tap it and put a screw into it if you wanted to. And it takes a long time. Cures in 15 to 24 hours. And that's, again, the trade-off if you want... So, super glue, you want the thin stuff that sets real fast to be the strongest. Epoxy, the stuff that sets the longest, tends to be the strongest. So that is the plan on that. And then after this stuff is fully cured, I'll probably have to do several passes to fill in the voids and get it all sanded and perfect. I'll use some Bondo glazing compound, perhaps, if there's some small imperfections. If there's a lot of nicks in the paint, I'm guessing there's probably going to be a chip here or there in the cabinet. I figure I'll fix the cracks first before I strip it, because I don't want to get stripper down in those cracks and then have to clean it out. And then there is the electrical portion, which I expect will be fairly simple. So as I showed in the first installment, electrically this is in really good condition. I think this is all original. All the tubes are Philco branded. I didn't see any evidence of work. And the only issue I've seen so far is that the roller does not engage the power switch and volume control. I can see there's a clip on here. So I imagine this comes apart and I'll figure out why it's not engaging. It might just be a matter of some glue. I do have the same as photo fact for it. It's a very conventional All-American 5 type design. I think it will be a very straightforward restoration, assuming I don't have a problem like a burned out output transformer or bad IF transformer. So I'll test the tubes, get this guy out, and before I even bother with this, I think I'll get it working. 3 electrolytics, a few paper caps, and go from there. So that's what I'm going to do first. I'm going to test the tubes, tack in replacement electrolytics. I'll just clip the original out and replace the paper caps and try firing this up. Alright, so let's see what kind of trouble I can get into. I already opened up the Loctite super glue, and I have not used it in this container before. It's kind of cool. The way it works is when you first open it, you turn the cap clockwise until it stops clicking, and then actually punctures it. It opens up the nozzle, and then you can squeeze the sides and you get a very fine drop out of it. In the past I've used cheap stuff where you had to just clip the ends of it off with some nippers, and they would usually dry out. Pretty much just good for one use. So let's see if this doesn't dry out and I can use it again and again. Alright, so yeah, I want to clean this up so I can pull this crack in tight. See, it opens up quite a bit there. So it actually goes all the way down to here, and then it goes up down here, and there, and there's a big hole and down that side. So it's kind of a lot to all clamp and glue at once. I think I don't have a whole lot of choice about it. So I'm going to blow out dust with some compressed air. Spread this apart and out. Let's see if I can pull this in tight. The side is coming together nicely. Right there, it's really good. But this top is not cooperating. Yeah, I figured this was going to give me some trouble. Now, another thought occurred to me, in addition to clamps, I could also tape it maybe. So if I can push and massage this to where it's good and tight, like right there, and then apply tape on this side and apply glue from the other, I might do it. Yeah, that's pretty good like that. Tough thing to clamp. If I was to clamp it here and here, it's just not doing it. You gotta apply pressure. Have an odd angle on both sides. So let me grab some tape. I got some electrical tape here. I don't think that's going to quite do it. I'll try some painter's tape. Well, I got some masking tape here. Let's give that a try. I don't think electrical tape's going to work because it stretches. And if I put a lot of pressure on this with the tape, it's probably just going to spread apart. So let's see how this does. Kind of wish I had 3 hands right now. So I'll try putting some tape on one side of it. Push it. And then spread the tape over. Yeah, that worked alright. Need some more. Push more here, get more tape on there. And again, since I'm going to be stripping and sanding and all that, even if some glue was to seep through or I get some adhesive residue on here that binds to the glue, not end of the world. And I got to admit, this is my first time doing a serious Bakelite restoration. I do have an Admiral 19A11 Bakelite 7-inch TV where the top had extensive damage, and that's a large Bakelite cabinet, much larger than this. And I just kind of push together as best as I can and just put a whole lot of glue all around it. And it's okay, but it's got voids and whatnot. If this works out well, I may go back to that cabinet. And it was so damaged, I figured it was kind of a loss. Because that cabinet is so nice, I figured it wouldn't turn out so good if I had to paint it. And it was so damaged, I didn't think I could get the Bakelite looking good enough on its own. So kind of in disgust, I just sort of glued it to hold it together. But, you know, maybe it's worth trying to fill in the voids and glue it up better and then paint it. Alright, so now we get this guy. I'm going to try a similar thing on this side. I think this is really the only crack I have to deal with. The rest of it is chunks that are missing. Alright. Seems pretty good. Yeah, it's not holding quite tight enough. I think this I will have to put a clamp going this way. See what I got. Well, all I could find is this big bar clamp. I know I got some smaller ones, but since we moved over over a year ago. Honestly, can't say I've seen them, so I have no idea where they are. Now, before anybody chimes in, yes, there are other ways you can go about doing this. For example, I could glue a couple blocks on the inside, then use a spring clamp to squeeze it together. Also, I just remembered I did many years ago, well, 8-9 years ago, I had a Motorola 7VT2 Bakelite TV cabinet, 7-inch set, really cool set, that was completely split in half, right down the middle. And that has a lot of curves, and what I did on that set, that I could also do on this cabinet, I put some rope around it. I lashed 2 ropes, and then put a stick through them. Imagine this pencil here, and I turned it like a tourniquet until it pulled all the cracks in tight, and then kind of tied it off to hold it, and then glued it up. So I could do something like that too. But this is almost good enough, so I'm going to squeeze it a couple more times and put some more tape on there and see if I can get it tight. This is off a little bit too. I think squeezing this, put a little more pressure over here. This is still tight, but here it's off a little bit. I'll get it in the end. I want to get this all perfect before I lay down that glue. It's definitely a mistake I've made in the past where I laid down the glue and then scrambled with only a few seconds before the super glue started to set up and tried to squeeze everything together. I put a wood clamp on the side, and I think that has got the primary crack pretty darn good. So I'm going to glue that up, that crack from the corner along here, and then I will glue the crack on the sides separately. So I'm going to get my glue and squeeze out of the dispenser down into the crack. Getting a little sloppy. I'll wipe up the excess. I haven't used this applicator before. A little more comes out than I expected when you squeeze it. Down in the crack now. Just wipe up some of the excess and let this set up for a while. While we wait for the glue to set up, how about we test the tubes? So, a lot of people struggle with Loctite tubes, and I did too until I learned a trick of how to get them out. If you feel around the base, there is a bump. If you tip the tube towards the bump, the tube will come out easily. So there we go. So, as I've heard about these tubes, they were developed for either cars or the military or both. Idea being there's this ring. When you put it in the socket, there's some sort of ring under tension that locks it down and keeps it firmly in there, so if it's vibrating, like if you're driving along, the tube won't come loose. But that can also make it difficult to get it out of the socket, so remember about that bump, and you tip it towards that, the tube comes right out. So 7A8, local oscillator mixer, bumps underneath my thumb, tip it that way. we go. Try to rock that one back a little bit because it was kind of in the way of some other stuff. So there's this tube, there's the bump. Tip it away, and there we go. And this is the audio output tube. There's the bump underneath my forefinger. Piece of cake. And lastly, I think this is the IF tube, or second IF audio detector tube. There's the bump. And we tip it, and out she comes. Alright, so get this out of the way and get a tube tester up here and check it out. Now I happen to have the luxury of several tube testers to choose from. I could use my Hickok 600A, one of my older tube testers. It's got a couple tubes in it, a 5Y3 and an 83 rectifier tube. Got to let them warm up for a while. And then there are a lot of controls to manipulate for the particular tube type. On the opposite end of the spectrum, I've got a Hickok Cardmatic, where you just pull out the card for the tube you want to test, and you slam it in. It does all the settings for you. But it's big, heavy, and it takes a while to find the right card. And then I've got this, my Sencor TC162 solid state Mighty Mite tester, which I've been using more and more lately. As I've gained more experience, I've come to realize that testing tubes is subjective. You can test a tube that's got weak emissions, it'll work just fine. The only true test is in the actual device. However, there are a couple things you definitely want to test for. One is the filament open? And two, does it have a short in it? This tester is great for doing that. So, let's do the 7A8. So all I've got to do is put the filament on 6 volts, set the C control, the plate load to E, and when I test for emissions, I want to be on position 4, and it goes into socket number 9. Before we test for emissions, we want to test for shorts, so let's turn it on. Let it warm up for a little bit. Hard to tell if it's glowing because it's got so much getter all on the top here. It's completely silver and reflective, so we'll just have to see if we get some emissions. Well, normally I'd let it warm up for a little bit longer, but I don't want to have you guys just sit here and wait for the tube to warm up. So rotate it through the shorts. If the light stays on, you've got a short. It's not, so let's check for emissions. Emissions are good. This also is very sensitive with the grid leakage. That will check for if the tube has been used hard, some of the cathode material may have evaporated and deposited on the grid, which can affect the performance of the tube, so that's what this checks for. And this has no grid leakage, so this tube should work just fine. And now I'll go through and check the rest of the tubes. So it's a 7A8. It's pretty impressive considering these are the original tubes as near as I can tell. I mean, it's possible they went to a Philco authorized service center and they replaced them with Philco tubes, but since all the graphics are identical, it makes me really think that these are the original tubes. So far, all the tubes have tested like new. I'm just checking the last one now. One thing to be aware of these is quite dirty. It's tempting to clean them aggressively, but beware that the printing on top is robust. You can rub and clean it. It won't come off very easily, but the stuff on the side, slightest bit of moisture, water, alcohol, anything, it'll come right off. So just, if you want to see the numbers better, make the tubes look a little pretty, clean the top carefully, but don't touch the sides. And even the top, if you start getting aggressive, the numbers will start wearing off too, so take it easy. I've just been licking my finger a little bit and just kind of going over it just so I can read the numbers clearly. So 14B6. This one has 3 separate tests because it's a multifunction tube. All the tubes have tested well into the good with no grid leakage at all, so that is just great. G5, excellent. And the last test is 6. So all these tubes test great, which is crazy considering how beat up the cabinet is. It make you think that this thing saw a ton of use, but considering all the electronics look to be original and all the tubes are original, it may not have seen a whole lot of use. Alright, so now back to the chassis. It's got some dust, but I don't see any corrosion. Very easy to work on because between the speaker and the loop antenna balances perfectly when upside down, allowing easy access to the insides. So we've got a 3-section electrolytic that definitely has to get replaced. And we've got 1, 2, 3, 4, 5 paper caps. I think that's it. That may be a paper cap. I think that's actually across the AC line. That's definitely got to get replaced. I have a feeling that, let's see, where's the schematic? I think it's this guy right here. As you can see, one side of the line goes to ground, but don't be confused. So, it says right here, this symbol denotes B-. This symbol denotes chassis. One side of the AC line does not go to the chassis. This is not technically a hot chassis set. They are connected via a 150K resistor and a cap and a coil, but they are not directly connected. So in other words, this line, this is the return for the actual radio. That will be all wires underneath the chassis, not the chassis itself. So anyway, I think that's what this guy is. I've seen that before in some TVs. These very large looking Bakelite things are what they use for the AC. In fact, I can see one end of it is going right to this, which is the power cord. And the other end is going to this guy, which looks like it's going all over the place. It's probably the B-. Now I do see a splice here. So I was thinking this was all original, but perhaps this cap is a replacement. These guys are so gooey it's hard to see, but I think that is a Philco part. This definitely is. There's Philco on it. Underneath the wax here. Hard to see it. Philco did label their parts with Philco. But this guy, other end's going over here. I think this is a replacement. 0.2 microfarad. So I think it might also not be the right value because I don't recall seeing a 0.2. Yeah, there's no 0.2 in the parts lists. We got a 0.04, that's the AC line filter, and 0.1, 0.02, 0.01, 0.01, 0.05, 0.05. That's it for the paper caps. There is no 0.2, so whatever this is in here for, it is not the right value. Let's see, it's going over here, going to the band switch, it's going to the antenna. Let's see if I can suss out what cap that's supposed to be. It might be this guy. Which really isn't strictly necessary. It provides, I keep saying that the chassis is not connected well, but notice some of the RF circuitry is going to the chassis. This provides a return path for RF energy. So it's, in terms of RF, high frequency signals, the chassis is ground. But as far as DC is concerned, the chassis is isolated from ground. Well, I'll figure it out. Now this is a goofy component. I was just reading about this online today. I've seen radios where there is a capacitor with wire wound around the outside, like separate insulated wire like this wrapped around the outside. But I've heard other guys say that this is actually just looks like a regular cap. And an inductor is just an inherent property of the capacitor. Because I sure don't see any, obvious coils down in here. Well, as I work on this, I'm sure it'll start to make sense. So this guy's going to go. I'm going to unbend this strap here, pop this guy out, clip these leads off, and tack in new caps just to get the radio going. And replace all these guys with some modern film capacitors. Well, it turns out I was wrong about the base. It actually has a bunch of hairline cracks. Every corner is cracked. And there are some long ones, like running from here all the way down. There's some chips out too. And that's where the screw holes are on the back too. It's cracked there. So I'm gluing up this too. Use tape again to hold it together, but doing something a little bit different this time. A trick I bet some of you know about, which is baking soda. Turns out that baking soda will cause superglue to set up virtually instantly and really hard. So I've used it on these cracks already. And now I'm getting ready to do it on this long one here. It starts here and runs all the way down. They're really tight, really clean cracks. So repairs are going quite quite well. So I'm going to run super glue again. Done in there. I already cleaned this out. And then I will just sprinkle some baking soda on. It can get kind of warm, especially if the super glue is thick. A bit of it kind of chunked off there. So it's not instant rock hard, but definitely sets up faster, and the baking soda does get embedded in the glue. That's why I left the slop on there, because I don't care so much about this as the stuff that's down deeper in there. I don't recall the exact reason this works, but it essentially acts like a catalyst. It certainly speeds up the repair process. So yeah, now that's set up real hard. And if I want to, I could just scrape that off or sand that off. So, 3 of the cracks done. The only one left is this corner, which is the worst area. Kind of a compound crack running through the corner and through that hole. But amazingly, none of the pieces broke off. I mean, this one's just barely hanging on. But I think it's actually cracked all around through here. But maybe it's just the pressure of the sides holding it in place. I'm glad it's all still there. I was trying to tighten up this corner in preparation for gluing it when it broke out. And now I know why I couldn't close that crack up tightly. Somebody glued this already. And they did not do a very good job, so I'm going to need to scrape this crud away. And I'll try to dissolve it with acetone. Acetone will dissolve super glue. Let's see if I can get this back on there tightly and glue it up properly. This corner, that crack just wasn't closing up tightly. Alright, I'm done with gluing up all the cracks. This top came out especially nice, really tight, and everything's even and nice and strong. Well, of course, we got a big gaping hole there, so that's what I want to try tackling next. Now, it's a little annoying that we've got these vertical supports here for this bracket that attaches to the bottom of the cabinet, because it runs up right next to that hole. I cut out a piece of this fiberglass mesh, and what I want to do is get it down in there and then apply the JB weld on both sides. But of course we got that in the way, so what I'm going to try doing is position it as best I can and then put some tape around the edges to hold it in place, and then mix up some JB weld and start slopping it on. I expect it will take a few applications on both sides, so it'll end up being something like that. I got that mesh taped up in place. Here's how it looks on the other side. So next up, I need to mix up some JB weld. It's a two-part product. You want to use half of each and mix it up thoroughly. This original Bakelite was fairly thick, and I want to do this in a couple passes rather than try to build up all that thickness at once. That's enough of that. This stuff takes a good while to set up, so I got plenty of work time. Let's see, that's about half and half. Alright, so mix it up. Doing this on top of the instructions. Sets in 4 to 6 hours, cures in 15 to 24. Alright, so like I said, plenty of time. Unlike epoxies you may be used to, this does not dry clear. Dries pretty much the same color it looks like now, which is a silvery gray. I do believe it's got powdered iron in it, but it really isn't all that conductive. If it is at all, it could very well be because the iron particles are surrounded by insulating epoxy. In spite of this being the ugliest damaging, this is actually going to be the easiest thing to repair. I think it's going to be really tough. Well, not on this top piece. Let me grab the bottom piece. I think it's going to be really tough is this chewed up edge. And I'm still at a loss as to how this happened. I mean, it really looks to me like somebody used the tool like nippers and went along and just chewed the edge of it off. All along there, and here, and back here. So I have to apply JV weld and a bead, probably several applications, and then file, sand it down, matching the original contours. That's going to be fun. But for now, I'm going to take care of this hole. So, just putting it on. Try not to slop it onto the areas that are in good shape, so I won't have to sand them later. And then I'm going to want to apply some on the inside as well to really reinforce this corner. And then when it gets down to the finer layers, I'm going to have to try to match all the original curves as best I can. Eventually I'll have to sand it, and if I sand too far, well, I'll just have to put more on and sand it down again until I get it right. So, pretty simple process. I'll let that sit overnight. Apply some more. I expect this is going to, between this and the bottom, it's going to take me a good week of letting it cure between layers and building up thickness.